Yeah, good morning students. So this is our third experiment. Now today we want to do this thing. So what is the third experiment agenda is, we need to implement a LAN using 6 to 10 nodes. Here n number of nodes means, so generally it is mentioned in the problem 6 to 10 nodes. Now compare the throughput by changing the error rate and data rate. So you must and should compare that both the things. So how the error rate is changed with respect to data rate, and if you change the error rate, how the throughput is changed. If you change the data rate, how it is changed. So like that we need to see. So in this only some changes you need to make in TCL file. Direct scenario doesn't work because we need to write our tool commands. Okay, so the TCL is already, it is a tool command language. So here we are going to write TCL lot of additions you need to do. Okay, previously we doesn't do anything, directly from scenario we executed. So but here must and should I need to do with respect to TCL files only. So this is the, so on desktop there is a DCN lab. On DCN lab experiment 3. So I created a folder experiment 3. So in that AWK file only there. Now I want to generate the TCL file. So for that Alt plus F, Alt Control Alt T. Okay, once you press Control Alt T, so CD space desktop. Next to CD space where I am executing the program and where I am using, so that thing, so must and should be there only. So CD space DCCN lab. So done. So once I am at the path, so directly type Java. This is a common command, so every time you are using Java space jar nsg 2.1 dot jar. Okay, so then you got this scenario. So this is the scenario. So here I am taking, so same a new wired scenario I am taking. So there are, so a single time also you can take, a horizontal chain also you can take. So at a time how many nodes I want? Actually I want 4 nodes. So this is one LAN, and one more 4 nodes I want. So that is nothing but simply just if I hit on this thing, so I got. So I want to change the scenario also, so like this, 4 here and 6, 5, 1 and 7. So like this, some distance also I will maintain. So this is the LAN, complete LAN. Now, so by using a link, so that is directly a drop tile I am taking. So capacity this much and the queue size is 50. So I am not changing anything. Directly I am connecting these two. Okay, there is a full duplex. Then after that, I want to connect N1 to N7. Just N1 to N7 I want to connect, because I want to send, my interest is, my source is N1 and I want to send my information to N7. Any nodes you can take, so like that. So here I am taking UDP and sync. So UDP means automatically you need to take sync as null. So then here it is 1000. So once that is done, directly you need to connect these two. Once that is completed, you take an application. So application as CVR. Okay. So this is the source node with application CVR, and this is the rate. The rate is 1 and the interval is 0.005. Then here I am taking certain parameters. So directly out.tr, I am not changing anything. So then generate the TCL. So generate the TCL So here you need to concentrate here only. A lot of things I want to add here, because the node definitions and everything I want to mention. So this is a separate, these 4 nodes are separate LAN, that is nothing but this is one LAN and this is another LAN. So one LAN communicate with another LAN. So like that I want to mention. So that means here I want to change the color coding and everything of these things. So save, first I want to save. So this thing in a desktop, this NLab and experiment number 3. So in this experiment number 3, exp3.tcl automatically it will take. Okay, done. So once I completed with that thing, so directly I want to go to my folder. So experiment number 3. So then this is the Tcl file. Open any editor, so G editor or any editor you can use. So directly I open this thing. So this is the file generated by the scenario. So in this I am adding from here. Okay, from here onwards I am adding. So the link definitions and everything. Just error also I want to add. Agent definition, link definition, application definition. So these are all things. Termination. So okay, so these all are okay, but up to here I want to do. So I have some code, already predefined code. So without time wasting I wrote that thing. See, here I will explain what are the lines I added. So this is for color of dropped packets, and data movement. Okay. How the data movement is showing in NAM, it is decided by here, this color, okay, blue color. So next these nodes. So these nodes, so red, so all these red are there. So these all are for node 0 to node 3. So these are one separate LAN. So this is one LAN or LAN 1. LAN 1. And this is for LAN 2. Okay, these all are for LAN 2. Okay. So now here N1, so it is a source. Because I am indicating on that thing, so I am labeling that thing. So that is nothing but source is nothing but my first thing, source UDP, and 3 is nothing but my error node, and 7 is nothing but my destination node. So that is null. And here the connection. So I want to make a LAN, between 0, 1, 2 and 3. So with 100 MB and 300 milliseconds LLQ and drop tail to MAC 802.3. I am using the frame relay. I am using here. Next, here make LAN in between N4 to N7. So same attributes. Okay, I am not changing anything. So next, after that, the link definitions. So here we have certain link definitions. So like NS duplex link. So this is the drop tail end, and the color, that is nothing but duplex link. Optionally the color, that is nothing but it is moving in the form of green. Okay, that is nothing but 3 to 4. I am showing the path as a green color. Next, to set error. So this is very, very important. Here only at node 3 I am setting error. So NS loss model. So here we are generating a loss model, that is error at N3 to N4. So in between them only I need to. So how I need to change this rate? The rate I need to change either 1, the error rate is 1, error rate is 0.3, error rate is 0.5, like that. So if you want to understand more thing, so you can do 3-4 times this execution process. Next, after that, agent definitions and application definitions. This is common. So, and one more thing, the data rate also you need to change. So here the set rate, So here 1.0 MB is there. So this one also you can change to 0.001. Okay, so from 0.1 MB first, next to 0.5 MB, next to 1 MB, like that we need to change this thing also. So here both the things you need to change. The data rate is nothing but this thing, data rate change. Okay, data rate. So in application definition there is a data rate. So change to 0.1 and or so 0.5 or 1.0. So like this you need to change. So these things. Okay. So with respect to these things also you can change. So how many times you want to iterate, that is our wish. So according to your understanding. Okay. Once this is done, just I want to make first time I want to make this thing as 1.0 only. 1.0 MB. So then save. So my TCL is ready right now. So now I want to execute the TCL. So Alt plus Control plus T. One more terminal. CD space desktop. Here next to CD space DCCN. Next to CD space DCCN lab. Okay, so then CD space exp3, exponent number 3. So once this is done, directly type ns space exp3 dot tcl. Okay. So some errors are there. So here at line number 3 ns color 0 blue, the color dropped packets and data movement. So here some error is there. So I want to check what is that. So color line, warning argument should be self class ID name. Well, I will see what is exactly that thing. ns color 0 blue. Okay. Yes. Here the packet movement and there is no change. Okay. 0.5, so 1 MB. So save the problem. Trace 8 nodes. Okay. Then color ns color 0. Set ns same. Example exp.tcl line 27 color ns color blue. Drop packets. Simulator color line. Wrong argument should be if it is blue, what is the problem? Node definitions and nodes, so it is 0. While executing, set NS node LAN 1. Okay. Okay, so simple. That one is nothing but what I wrote comments. So that comments are indentation error is coming. So this is the actual scenario I got. So once I executed that program, so just edit the scenario, just go here and rearrange the terms. So here edit is the option. So rearrange these things. So 1, 2 and 3 nodes. So once that is done, so directly I want to go with 4. This side is 4 and this one is 5 and this is 6 and 7. Okay. So now the data, how it is moving, I want to see. So once editing completed, just this is one LAN and this is another LAN. So directly just stop and execute with some delay. That is nothing but somewhat fastly I want to execute. Data state started. Now packets are dropped at 3 to 4. Okay. 3 to 4 packets are going to be dropped. Okay. So like this you need to execute. So same way, for suppose here the problem here is nothing. So previously I added some lines, so there is nothing but what is this thing and what is that thing, like that. So this one is for, so the color of data. So this is the color of the data what I mentioned here. So next here one thing, that is 8, because in throughput I wrote 8 everywhere. So that's why I need to run. The stop time is 8, start time is 1 and stop time is 8. Save. So once again, so I want to execute the same command. So rearrange the packets if you want to better visualization. So then go with this thing, otherwise this thing also. So 1, 2, 3, then so this is 1, 2, 3, 4, 5, 6, 7. So the LANs, 2 LANs are done. So like this it is connected. Choice is yours. So how you want to arrange or how you want to. Okay. So then Just this is the source UDP, and this is error node, and this is destination. Data is moving. So some packets are dropped here, so that blue colored thing is dropped. Okay. Like this it will run 8 seconds now. If I want to increase the speed, I can. So this is for visualization purpose, how the data is moving in a LAN to LAN, so with n number of nodes. Okay, so one simulation is completed. Now I need to analyze, that is I need to calculate the things. So for that must and should require AWK file. So here I am generating some variables. So these are the variables. One is sent packets and dropped packets, received packets, and time, how much time, and throughput. So these are all the things what I want. So first thing, the total number of packets sent at node. We know the total number of packets dropped at node 3, also known the total number of packets received at node 7. So here the time, so I can use time as this thing also. So time is nothing but $2 every time. So instead of 8.0 I can directly print time, because 8 seconds around it will come. So then the throughput is equal to, this is a received packet, number of received packets, and this is nothing but, this 1000 is nothing but the CBR packet size. Okay, then time divided by 1000, so it will give the throughput in kbps. So this is the throughput what I am printing. So like this I need to generate AWK file. After this just run AWK. So AWK f exp dot awk dot the space out dot tr, because out dot tr only I need to analyze. Done. That is 3995 point, so that many kbps. So that is the value generated by the thing. So if you want to tell in mbps also you can tell, but here I am telling in kbps. Same way, this is one time. So one more time if I want to observe, directly go to this thing and edit the TCL. Now data rate I am changing. So here the data rate is 0.5 MB. So I changed the data rate and save, and once again comments I'm going to apply. So this is the TCL file. So now I don't want to arrange once again, because already I know how it is running. So like this the packets are going to be dropped. So after completion of execution, just once again I need to type awk.tr. See, so here the packets, data packets sent only 438, because I decreased the data rate. Yes, the data rate is decreased and the everything is changed. So in kbps it is showing. Okay. So same way, if I want to increase error rate or decrease the error rate, the throughput is affected. So same data I want to increase or decrease the error rate also. Now see, so here the error rate is 0.5 previously. So if I decrease that thing, error rate is 0.1. Save and apply these things. Okay, so then execute somewhat fastly. So you can easily observe that the packets are only some percent only going. So then after completion, then once again I need to run this thing. See, 438 only data moved, but previous one, this one, if you compare, see 438. So the data packets received at node 2 is 200 and dropped 238. So in this 438, so 53 only dropped and 385 received. So that means I established a LAN and I completed my experiment according to the requirements. Okay, thank you. So this is done, and we can write the result and do NS2. So this is the third experiment completed according to the requirements. Thank you.